Hello, Bio30. Welcome to the presentation on threshold potential. We're going to be drawing in your notes just below your neural transmissions. So today, what are we actually learning? In this lesson, you're going to learn how an action potential is formed by electrochemical gradients, which essentially is just the movement of the ions we talked about in our last video, and how this is then transmitted along a neuron. We're also going to learn a new term called the all or none response in conjunction with how our body responds to the intensity of different things that can occur to us. So in the space provided that says draw and label an actual potential graph, you're going to do the following. You're going to draw a y-axis and an x-axis, labeling time on the x-axis and membrane potential in millivolts on the y-axis. You'll notice that 0 is kind of halfway, a little more than halfway up. So the first set of numbers from 90 to 10 are all negative, and then 10 to 60 are positive. Because as a reminder, when we have a nerve impulse, we swing from negative 70 millivolts to a positive 35 during depolarization down to 90. We're going to see that in this graph. Once you've drawn your X and Y axis, you are going to add in a couple of really key lines. We're going to start here at negative 70. We're going to have a little bump right there, just a small one, maybe almost up to 50, but not quite. And then you're going to see a little bit of a dip back down to 70. And then you're going to cause a big increase, swing up to about 40, back down again to negative 90, and then level out again at negative 70. So once you have your two axes drawn and you have this lovely lines drawn, we're going to start labeling this graph and explaining what's occurring. One more key thing you need here, ladies and gentlemen, is some numbers. So we have 1, 2, 3, 4, and 5, as well as a dotted line at about negative 55, so in between 60 and 50, and we're going to label that line called threshold. I'm going to talk about that word very briefly in a few seconds here. So what is happening in this graph? Well, the first thing that's happening is at star 1, or at number 1, this is what is called the rest period of a neural impulse. The sodium and potassium channels are kind of open. You have the sodium-potassium pump working, moving sodium back to where it belongs, outside the axon, and moving potassium back inside the axon. And it's building up this membrane potential of negative 70. That's why the line is at negative 70. So something happens where a small impulse is detected by the neuron. So that means the dendrites and the cell body detect something and try to make, does it need to be passed along? It's kind of thinking about it. And what happens is the sodium channels start to open slightly, but they don't actually open enough. There's not enough of a push from the cell body to make the sodium channels open up. So sodium doesn't quite open up, so sodium doesn't rush in. There's no impulse, essentially. There's nothing, even though there was a little bit bump. This is because that dotted line we have right down along negative 55 is what we call the threshold. The threshold is what is designed for our neurons to have to meet in order to have an impulse. And once it has an impulse, which you can see is kind of starting right here, this effect is called the all or none. Once threshold is met, once you hit this lovely, special, magical number, you will always have an impulse, no matter what. And that is the all or none effect. So currently what's happening at stage 2 is that a small impulse was detected, but not enough to break threshold. So nothing happens and it goes back to normal. So we call this the nothing or the none because nothing happened. What then happens is then the cell body gets another impulse detection, and this one goes, oh yeah, this is pretty large. We need to deal with this. So the sodium channels open way up. They open all the way up. We're going to have depolarization or an action potential. And so sodium floods all the way into the neuron, and the charge jumps all the way up to positive 40 millivolts. And that's what we're seeing here. So this section here is what we would call depolarization or an action potential. So now the impulse has passed down the axon, the sodium channels are closing, and the potassium channels are opening up nice and wide to move potassium out. This causes the charge, like we said, to overshoot down into -90, which is what you're seeing here. So this charge goes all the way down to -90 because potassium rushed all the way out. But now we need to fix this problem and go back into resting, which is what we're doing at number 5. We're starting back at rest. So to kind of refresh, guys, this idea right here, this nothing to all, is called the all or none effect. If you don't meet threshold, which is right here, you will have no impulse. If you meet threshold, it is going to happen no matter what. So if we were to look at what is happening at each phase 1 would be called polarized. And this includes 2 because nothing happened, the sodium channels did not open up wide enough. Number 3 is what we would call depolarization or an action potential is occurring. And between 4 to 5 is when we see our repolarization or our recovery periods, part 1 and 2. So the next part of your notes says, now that you have an action potential graph, let's talk about your intensity responses. Why do you feel a much lighter touch when someone taps you on your arm versus if someone pinches you on the arm in the exact same spot? So why, if someone taps you, does it feel slightly different than if someone pinches you? In fact, sometimes pinching really hurts, right? So what this is you have the same number of sensory receptors on your skin wherever that you got tapped or pinched. You have the same number of sensory receptors. That doesn't change. And their response does not change. Okay? Just because you feel a pinch more than you do a tap doesn't mean that this graph goes any different. It does not mean that you all of a sudden have this massive overshoot over here. No, it's all or none, and it's the same thing every time. What is happening is in the tap that you receive, maybe on your shoulder or on the side of your arm, only half of the receptors in that area meet your threshold. So let's say you have 100 receptors and only 50 of them meet the threshold and fire the impulse to your brain. That's going to feel a lot lighter than, let's say, a pinch, where maybe 80% of the receptors meet the threshold that is located in the area and fire the impulse to your brain. So it's actually your brain that interprets the touch and how intense it feels compared to the actual receptors itself and the neural impulse that is occurring. Your brain interprets that the pinch was harder than the light touch because only some of the neurons fired with the light touch, where the pinch much more did. So your brain does that interpretation, okay? And what it's doing is it's interpreting that all or none effect. Half of them gave you that all or none effect, so you only notice that it feels a little lighter, okay? So your sensory receptors are the ones that are sending the information. Their impulse intensity, how hard that against, I guess, the impulse is passed, that never changes. It's all or none. In our case, for a average, it's going to be -70, has to meet -55 millivolts to beat threshold, shoots up to positive 40 or 35, and back down to -90. So when you feel a much lighter touch when someone taps your arm, it is because of this lovely idea of threshold. You're only meeting some of it. And so you still get the same impulse, but in only some of the neurons. Hopefully that makes sense. Please maybe write down somewhere where all or none means. I've repeated it a couple times just so that you have it when we go over that vocabulary word. So in this lesson, you have learned how an action potential is formed by sodium and potassium moving, but how it's transmitted along a neuron. But you also have learned all or none responses in the world of intensity and response functions. If you have any questions, please let me know.